Alright guys, welcome back to this radical lesson 6.5. We're going to finish this up here. This shouldn't take too long. Multiplying radicals and then looking at conjugates. So multiplying radicals is actually pretty straightforward. So to multiply a radical, especially that are in this form where you have multiple pieces here, you're just going to FOIL it. So really remembering your FOILing method. You're going to take the first term, multiply it by the first term in the other one, then do the outside terms, then do the inside terms, then do the last two terms. Okay, that's what FOIL means again if you're forgetting that. So let's do the first terms. So when we do that, we get 6 times 2, which is 12. Then, so we're going to multiply the whole numbers first on the outside, and then the radicals, right? So square root of 3 times square root of 5 is the square root of 15, which cannot be simplified. Okay, and then I keep going. So let's do our last terms. So this will be plus 24. Square root of 3 times square root of 2 is square root of 6. Okay, now let's do our insides. We have minus 10 root 5, and then minus 20 root 2. All right, nothing can be combined here. There's no like terms, so we are done. On to the next one here. This one's a little interesting. We have this one, 7 root 2 times 7 root 2. That's the same thing as 49 times 2, right? Because the square root of 2 times the square root of 2 is equal to the square root of 4, which equals 2. In fact, anytime you have the square root of something multiplied by itself, you get that same thing back, because that's what we're undoing with roots, right? So we have 49 times 2, and then if we did this one, it would be plus 21 root 3, and then that guy would be minus 21 root 3, so those cancel. And then my last term would be minus 9 times 3, because square root of 3 times square root of 3 is 3. Okay, so use parentheses there so we don't get it confused with anything. So 49 times 2 is 98. 9 times 3 is 27. When I subtract those, I'm left with 71. All right, so that's multiplying radicals. Pretty straightforward. Just remember your FOILing process. The conjugates, I'm not sure what you remember about these guys, but conjugates are very important in solving these radicals. The problem with radicals is we have things like this, where you have 3 over, you might be left with square root of 2 plus 1, or something like this, right? One of the things that students like to try here to get rid of, so let me back up just a minute. We cannot have radicals in our denominator. Okay, if it's something that's truly simplified, we have no radical signs in the denominator. Okay, so this one does, therefore I have to get rid of it. And what a lot of students like to do to try to get rid of it is they're like, oh, well, I could just multiply by square root of 2. Okay, but if you do that, remember that that applies to both pieces, right? So if I end up doing that, I get 2 plus root 2, and the radical did not disappear. In fact, you can't multiply that by any single expression like this, so, or I should say just single term like this. So what I need to do is I need to use a conjugate. So what this conjugate paragraph is saying, I'm going to show you with an example, is it's essentially just saying this. It's saying we cannot multiply by one piece, you have to always multiply by 2, and when you do this, you must just change the sign of our original and keep the terms the same. Okay, and watch what happens when you do this. When I do this, square root of 2 times square root of 2 is just 4 now. Sorry. It's just 2. It's the square root of 4, which is 2. And then square root of 2 times negative 1 is negative root 2. And then 1 times square root of 2, notice I'm just FOILing this out, is just root 2. And then 1 times negative 1 is negative 1. These cancel, and what I'm left with is 2 minus 1, which is 1. Okay, now my radical is gone. It can still be in the numerator, so don't worry about that. The numerator's fine, so if I take 3 times the square root of 2, I get this 3 square root of 2, and then 3 times negative 1 is negative 3. Okay, since I'm dividing by 1 there, I only worry about what's in the numerator, and I'm done. Okay, so that's a conjugate, when you just multiply by the exact same thing, but you change the sign of each term. Sorry, of just the middle term, so that everything cancels. So let's look at another one of these. Here's example 6. Okay, to get this thing, to this radical outside of the denominator, what I need to do is multiply by a conjugate. So this is square root of 5 plus 1, square root of 5 plus 1. Okay, when I multiply this out, I get 2 root 5 plus 2 on the top. And then when I do the bottom out, I'll just show this to you. This times this, square root of 5 times square root of 5 is 5. Square root of 5 times 1 is positive square root of 5. And then negative 1 times square root of 5 would be negative root 5. Those will always cancel. And then if you do this right, and then negative 1 times 1 is negative 1. So on the bottom I have 5 minus 1, which is 4. Okay, but I'm still not done here. Hopefully you see that. You're still not done here. In order to finish this thing, what you're going to need to do is you're going to need to ask yourself, is there anything that's in all three pieces that I can take out? And the answer is yes. I can take a 2 out of everything. Okay, so if I take a 2 out of everything, I'm left with the square root of 5 plus 1. Don't forget, when you take a 2 out of 2, you're left with 1, over 2. And that would be the full simplified form for example 6. Alright guys, the last thing that I think I need to show you is, this might be coming out, I think I'm going to take one of these from your homework. Let me just see here. Oh, looks like they don't give you any of those really hard ones. Never mind, we'll do that next lesson, where we have powers other than 2 in here that we need to take out. Anyway, alright, that's it for today. Now you guys are able to finish your homework.